Hi, my name is Tim Piermansky. I am a full-stack engineer turned data retraining researcher. I currently work at Essential AI, co-author of Essential Web 1.0, and I currently work at the petabyte scale, and I work pretty closely with Daft.
Hi everyone, I'm Vi. I'm the lead engineer at Voxel AI. Voxel does warehouse safety with computer vision, so there's existing security cameras within these warehouses and other industrial environments. We plug in our software and we identify risky behaviors that can lead to injuries.
You all met me already.
Likewise.
All right. Okay, I guess the big question about data that I have is, what does it mean to be multimodal? Like that, I think just to baseline everyone on like what we're even talking about. Who wants to take this? Actually, Shraddha, do you want to start?
Yeah. To me, multimodal is everything from just one value all the way to a complex data type like video. So I occasionally run into like, well, if you're a multimodal database, we're just doing text right now. So maybe, when we get to multimodal, and I think in people's mind, multimodal basically starts after text. And that's not true, because essentially what you're saying with multimodal is it's your row column data, it's your time series data, it's your text, image, video, documents, and everything in between. It's just when you put it together to accomplish some goal at the end.
Cool. Anyone else have like an answer to that question that they want to share that's slightly different, or are you all in agreement? We're all
disconnect.
Yeah, I mean, I think on my end actually, disconnect.
What did I do wrong?
I was
always connected to your answer.
just kidding. I was rereading actually one of the OG like Postgres papers, and if you read that paper, interestingly, one of the big breakthroughs that they had was, hey, you can now work on strings. Strings is a new type, and you can now work on polygons, right? And like that to me was a moment, and I was like, hey, like back in the day, strings were a huge deal. It was actually multimodal, right? Like, so I think to your point, everything is a modality, right? Everything has an encoding. Integers have an encoding. You can be little endian, you can be big endian. And then you go up to say JSON. JSONs have an encoding. They're strings, but they have a certain format, UTF-8, right? And then you can go to something more complicated like images. They have an encoding as well. They can be JPEG. They have a structure. And they're just a little bit more complicated and a little bit fatter on each row. But at the end of the day, data is data. And it's multimodal, I think, just means the entire spectrum from like integer all the way up to a video. But
yeah, no, one of my professors would always say even code is data. So
code is data. Ask the Anthropic guys in the back. Code is data.
Everything is data. All right. Okay. So the next question is, all right. Okay, we've established that what multimodal is, and now we're trying to maybe convince some organizations that they need some degree of multimodality, or some organizations realize that they need it, and they want to come to you to figure out where the ROI, where the value is. And I think I'll go at the very end. Tim, how do you go about either convincing an organization or talking to they're already at Spark? Where do we go from there?
Right. I would say that in most organizations, they carry data in a mess, in a Frankenstein of formats. You might have data within PDFs, and it might have complicated like charts and figures, or you might have existing databases. You might have JSON files. You might have code. When I think about convincing organizations for leveraging this data, I think to myself, there's so many insights there which we typically rely on people to interpret, people to scour through. But if we get high-dimensional embeddings of all of these different modalities, for example, you can build systems which can intelligently search much vaster spaces and use AI to leverage all of that latent information which is just sitting there.
All right, that's great. Thank you, Tim. Piggybacking on that, I think is just this idea that if you have all this information and you're making use of it or not, your organization is in a certain place. Me, when I run my businesses, if I'm trying to talk about this stuff, I typically frame it in terms of risk. Like, what is the risk of not doing this stuff? And Shraddha, I think you and I were briefly speaking about it, but Vi hasn't had a chance yet. So maybe we can talk to you a little bit about like, what do you think are sort of like the gaps that organizations currently have, where like you can step in and talk to them about like where they can use this stuff?
Absolutely. I mean, we're in a space that's constantly evolving, right? The way that we are including vision and language models, this didn't exist 4 or 5 years ago. So a lot of organizations are stuck where they were 4 or 5 years ago. And it takes a lot of inertia to break where organizations currently are to move to something else. So adopting new technology always comes with a switching cost. The question is, like, how much of a benefit are we getting to incur that switching cost, right? And especially when you're thinking about systems that already exist for managing data. Data is core to what a lot of businesses do. So any sort of switching can actually result in downtime or any other extra unnecessary effort. So it's one of those, you don't want to break something that already works well, but also what are the benefits if we switch? So it is a trade-off that you have to consider always when you're thinking about new technologies.
All right. Yeah, that makes perfect sense to me.
I would just add, just put dollars on it. That seems to work for everybody. Like, this is how much you are losing or not gaining.
Yeah.
Potentially.
Yeah, no, that makes perfect sense. And every time a proposal like that comes up, you put dollars on it. There's the proposal for the POC and the proposal for scale. How do you guys differentiate between like their scales of compute, their scales of data? There's a lot of things that we can talk about here, but let's talk about just going from POC to like being able to scale something like this. How does that typically happen? And we can actually jump right back here.
Yeah, maybe you can speak to our experience with Essential. We started working together. Essential was, really liking the Daft data frame, just working on a single machine. And they were, hey, can we get this to scale, right? And so we sat down, I think, for a couple of weeks, just running it on GCP infrastructure. Hey, what is your networking? Like, how do we get this thing to talk to your GPUs, which is way over there? And really just like knocking out these engineering challenges, which interestingly, I like to put it this way that some of the data systems that we have, such as Spark, such as Spark and Trino, have been battle tested for a long time by a lot of companies, right? And some of these newer frameworks like Daft require a little bit of the battle testing. And so someone recently told me, databases are like fine wine. People only give a damn after you've been around for 5 years or more.
Yeah.
And that's the reason why, right? Because like it really has to be battle tested at scale with companies that are kind of forward looking and tackling these new modalities and new challenges. Yeah.
Okay, so I guess maybe just following up on that, what do the next 5 years look like in terms of like getting companies to stick it out or to figure out how they're going to grow with you, or like, what are sort of the challenges in getting them to be involved in like the multimodal space? Wait, I should ask Tim. Let's go with Tim. Actually, you guys can volunteer to answer these questions. I'm just kind of picking randomly.
Sure. I want to follow up actually on my experience with Jay and like how we work really closely together, if that's all right.
Yeah, please.
I want to say that we pushed Daft to the limit, and it's battle tested. I want to say, I think the best use case that I can think of is the Essential Web project. We were dealing with common crawl scale data, so it was like petabyte scale data. Our use case was we wanted to run large-scale inference to effectively taxonomize the entire internet. And I mean, in our particular case, we're very lucky to have an incredible infrastructure team. So we're able to have people closely monitoring a dedicated GPU cluster. We have a dedicated GPU cluster, and for this we used, on average, around 512 AMD MI3000X GPUs. 300X, and they're blazing fast. Every single one has 192 gigabytes of VRAM. So what we did was we first, the job requirements were such that we wanted to drive the GPUs to be compute bound and not memory bound. And in order to do that, we first calculated what is the maximum performance we could get out of the GPUs. So like, what is the maximum token throughput? And our infrastructure team identified, okay, we can get up to around like 80,000 tokens per second on every single GPU. Now this specific job, we were taking entire documents from the internet, and then we were feeding it into the GPU, and we were asking it to output like this taxonomy, which is relatively small in comparison. So the output was actually pretty small compared to the input. And what we ended up doing was, why I love Daft so much is we first iterated very quickly. We were able to spin up a working solution, get it working locally very quickly, and read data from GCS, send a request to our GPUs, make sure that the output looked correct, where if we had to do the same thing in Daft, or in Spark, we would have to, load some, we would have to have the JVM installed. We would have to go through all of its nuts and bolts just to get something running. So just the time to get something running in the first place was a lot shorter. And then once we got it running locally, then we just scaled up to multiple machines. And all of the AMDs were firing on all cores. So it's certainly battle tested.
Very nice. Yeah, it's always nice when your compute's not being wasted, especially if you're paying for it anyway. I like the example. I think it was a really good one, but it was a little high level at documents. So one real world use case for multimodality that one of you's come across. Maya or Vishaka, you want to take with this one?
You have the videos.
Yeah, you got the videos.
You
guys
can
wanna do one?
describe your scale problem. I'll talk about the pain point that we solved later.
Absolutely. So I guess I can jump in and talk about the voxel use case. So the primary modality that voxel operates on are videos. We're running live in warehouses and factories around the world. We're actually on 5 continents at the moment, so running everywhere on thousands of cameras. When you have thousands of cameras running, you're actually getting several years of data in a single day. So this is a ton of data that's coming in. We're continuously processing it, evaluating it, running in real time, generating insights, storing some of it, throwing away most of it. So it's a massive amount of data that we're collecting. Once we have this data collected, we also need to annotate that data, store that data somewhere in our label store. We automatically annotate some. We use some human labels to annotate others. So we have a massive amount of data. We need ways to reference that data, query, filter, find the right data, so that we can use it to retrain other models, as well as have the right data sitting in a specific location so that our customers can access it through our front-end application. So just the amount of data that we have is massive, and of course leads to pricing and availability challenges.
That dovetails really nice into what are the challenges and what are the pain points in this? And Vishak, I guess you have pain points in general covered, but maybe we follow up on Vi after that. Yeah, go for it. You already had the mic. Go for it.
Oh, I was going to say even the scale problem comes even so Vi talked about just the volume, huge amount of volume. We ran into for one of the use cases, I didn't go too deep into the whole Badger Tech use case. They had robots going up and down grocery store aisles. Everywhere they stopped, they would take 6 pictures at a time, convert to embeddings, and then do vector search to figure out what does that image represent. Is it a cereal box? Is it an olive oil bottle? And if the olive oil is where the cereal box should be, the store manager should come fix it. If it's an empty shelf, they have to come fix it, because otherwise customers have a bad experience, they don't find the product that they're looking for. And before they switched to Aperture DB, they were using a vector database that, it could give them vector search, but as soon as they started scaling, and they were doing 4,000 vectors per second at that time, somebody had to be up at 5 a.m. in the morning to restart, because it would keep crashing. And that's not, and you're talking about a company that's manufacturing robots with so many things that can go wrong, and if it's the back-end database that's spoiling their scale, that's really that's hard to explain.
Yeah.
So that was the big reason that they switched over to Aperture DB, because they've now gone from 50 stores to 300 stores, and they're looking to grow into 3,000. And they need something that can keep scaling. So they're they've gone from 4,000 to 8,000 vectors per second, and even before we made it a distributed database, we could deliver 13,000 to them right off the bat. And so the scale problems comes at the volume side, but it can also come from how high throughput the use case is, and sometimes how many queries happen at a certain latency requirement. So that's the kind of scale problems that we run into in terms of solving from the database standpoint.
Yeah, that makes perfect sense. Are there misconceptions that companies have off the bat before they even get started? I guess this would be a great question for you, because you deal with a lot of companies. Can you hear me still? Okay, excellent. I couldn't hear myself for a second.
Yeah.
All right. So the question, just to repeat myself, is what kind of misconceptions do companies have at the growth? There are certain things that you find out in practice, but there's also certain things that you have to deal with upfront as you're trying to just get to the customer and figure out how to do multimodal.
Yeah. One recent one that actually I've really come across is that people will go, oh, I have a data platform, but we don't have multimodal data. right? It's all a Snowflake table, you know, it's all in Postgres. There's no multimodal in here. Like, we don't deal with images, there's no video. And then I kind of like started realizing, hey, like, what about your Slack? What about your Jira, right? What about all these like comments you have in Linear and you know, everywhere? And my hypothesis is also like, you know, does anyone here wear Meta Ray-Ban glasses, by any chance? No one? Yet, I think? Does anyone wear those like new like pendant things, the AI pendants, that like just record your life?
Like,
You know what I'm talking about?
Or something.
There's a whole bunch of them now, yeah. But, you know, back in the day, I think before Facebook was a thing, the primary modality on the internet was text, right? Like basically just like logs and like machine-generated stuff. And I think when Facebook really started exploding, that's when user-generated content became really huge, UGC, right? And I think we're gonna see the same explosion in AI. And that's really because like that's how humans interact with the world, right? We interact with the world in a very multimodal way. And already we're seeing these new modalities come into place in kind of like physical AI. And I think companies that aren't leveraging this information in their Zoom, in their Slack, and you know, all the ways that the people work in the organization are really gonna lose out. So yeah, when companies come to me and say they don't have multimodal AI, I'm like, I think you do. It's in your Zoom, right? What if you wanted to run a query across your organization asking it like, why were project deadlines not met in Q4 2025? That's where you have to find that information. It's in there somewhere.
Okay, yeah, and that makes perfect sense. It allows me to ask the next question also, which is, maybe it's for any of you who wants it, what's one like kind of unexpected finding that you had in sort of the use of multimodal data that the company wasn't expecting, or like was sort of like a big win, it came out of nowhere, or like you were able to leverage something that you weren't expecting from the beginning? Is that kind of unclear? Yeah. Good, yes.
I mean, particularly in our use case, we're training large language models, and a lot of the information which we train on is actually contained inside of visual information. So you can imagine like the internet contains tons of PDFs. We're calling the entire internet, and you know, there's a lot of textbooks. There's a lot of great content contained in PDFs. So at least for us, it might not be unexpected. It's pretty well known. There's a lot of great distributions contained in multimodal information. But what was unexpected was how much progress there's been since traditional OCR in terms of multimodal models for actually extracting text from in high fidelity from PDFs to text. So I mean, we are still in the works of actually implementing these OCR solutions, but current results are very promising.
Okay, I think you've already answered it, but I think I want to dive into this area of like there's new AI capabilities being generated every month, and there's new requirements based on some of that. You know, obviously video is a huge thing where you're actually able to parse the video as text. You're able to do like multimodal approaches. What new infrastructure requirements are you guys kind of coming up against? And this is for if you want to hit.
Yeah, so many things are changing, right? So when
Something
Voxel was founded, it was in early 2021, which is like pre-ChatGPT, right? If we think about what AI was like before then, our world looks completely different now. So a lot of the approaches that we started using then were things that look more traditionally like what self-driving car companies were using back then, with like cascading sets of like human curated rules, ResNets, things like that. But now as we're seeing this AI revolution and this multimodal AI revolution, it's really, really hard to keep up with everything that's changing out there in the world. So it's a question that we repeatedly ask ourselves. Is the approach that we're using the best one, like looking forward? And it's something that it's very important for us to keep up to date with is what are the best approaches in terms of experience for the customer, in terms of cost, and as well keeping ourselves competitive against our competitors too, and staying ahead of the curve. So something that we found that we need to find some dedicated time to keep up with. Every single week we're reading papers, keeping in touch with things, and also have built tools and frameworks that we can use to actually automatically evaluate some of these new systems that are coming out. If there's a new VLM that comes out, how well does it perform? Can we quantitatively know the answer so that we can actually compare and see how we're progressing? It's interesting. I think at the moment where multimodal AI is right now, the models that we have that are very specialized perform a lot better than the general VLMs in our production use cases. They're able to get that precision that we need in production. But we're rapidly seeing an improvement. So I feel like in 6 months that would be completely false for me to say that and completely change. So it's really cool to be in this space at this time and keeping your ear to the ground.
From the data side, what I would like to add is a pleasant development from the way I've seen people understanding evolve and kind of work in our favor a little bit too, is how people have started understanding the value of knowledge graphs. For some reason, I've always been in the graph camp because I imagine like the way things are connected in my brain, I see graphs. And it was always hard to explain to people why it matters, why it's important to be able to capture those relations, why it can be more efficient when you're trying to traverse things, and how it is the more natural representation. I mean, if you draw diagrams on how the world is connected, you draw a graph, and then you map it into foreign key tables, right? And then you do all these complicated joins to get to the information you want. And that somehow is the common case. So it's been exciting times to like see the value of knowledge graphs become clearer, but especially as we go more and more multimodal, because like a video captures a lot of people, it captures a place, it captures a lot of different sentiments and events and all these things, right? Or an audio has all these things. So representing all those things in a graph, and then like the next thing we are looking into, or like where we are going next, is this whole concept of agentic memory. And if you look at how human memory is, you can recall things from long past, which is kind of equivalent to what you can do with vector search or semantic search. You build all these connections between different things. That's your context or graph in your mind, and you're doing it from different modalities of data. Like I remember the least amount of things from what I read these days, more like more what I hear and what I see. So if you want AI agents to become to start showing deep intelligence, what I call, instead of shallow intelligence of just repeating like short-term things, you kind of have to start thinking about how would you realize that memory, and you come down to the fact that okay, you're going to need a really efficient and unified way of combining context, semantics, and multimodality, which is where what we've built with ApertureDB fits right in. So it kind of it's exciting times in that sense.
I have something here too on the
Go ahead.
On the inference side. Something I think a lot about is GPUs. I think it's very, very interesting. I'm kind of torn because there's this one story that I remember hearing from someone. They were talking about when credit cards were first a thing. Nobody trusted credit cards. They were like, oh, I carry this card around and like, can I trust it? Like, how am I going to lose all my money? But now today we just swipe, right? We don't care anymore. And this is almost similar to like how OpenAI and Anthropic are set up, right? Like today, a lot of people are very worried about do I send my data to OpenAI and Anthropic? Literally, if I'm running a contract with a super high value customer and it's a very privacy sensitive use case, is it safe to send it to OpenAI and Anthropic? I think the answer today is a big question mark, right? And we are seeing a lot of companies putting in a lot of effort into open source models, running it on their own GPUs and kind of taking part in that GPU race. And so it's also very interesting because there's this, the open source models are almost competing against the capabilities of the closed source ones. But I think my hypothesis is that actually a lot of the use cases don't require complex reasoning. And I think in my presentation I said, hey, context is king. Right, because you can get surprisingly far with a simple open source model, small amount of parameters, fine-tuned to your use case, and give it really, really good context. For example, if you have a use case around, hey, I have drivers, I want to see whether they're falling asleep, right? A VLM is going to do amazing on that. And just fine-tune it, run it on your own infrastructure, and people are going to choose that rather than sending their data over the wire to an external provider, literally just because of data security. And that's an interesting development because then this has tons of implications around people then needing the infrastructure to run these models, which I think is very interesting on the economic side of things. It remains to be seen what's going to be kind of the future here. But I'm betting on, I think, open source models becoming more and more powerful for a subset of use cases in the enterprise, and companies will want their own infrastructure to run this stuff.
Yeah.
But yeah, I also don't know if we're going to open the floor to like audience members, but we'd love to hear more thoughts on this. But,
Yeah, maybe we should hold like whenever we have 5 minutes left. Could someone tell me when we have 5 minutes left? Then we could just do like audience questions at that point. But open source, I think while we figure that out, I guess Tim, I think the question here is, how do you decide on what a good open source resource is to use? How do you decide if it's a good model, it's a good library, any of the above?
Because I would say number one is you have to like understand your requirements very well. That's the first step, and then the very next step is find evals which give you signal about the capabilities which you care about, right? If you care about object recognition within like images, look for evals which specifically target that. If you're looking for general common sense reasoning because you're doing multi-step like multi-turn conversations, try to find evals which are targeted towards that. And then just keep an eye out for what the latest open source models are. Currently there's a lot of great open source models, Quen is putting out great models, Kimi 2's just came out, it's incredible. I think there's a lot of momentum picking up in the open source world. And then I would also, I think something that's important to understand is, do you require a large model or do you require a small model? And that decision, really comes from what are your latency requirements as well, right? If you need incredibly snappy responses, almost real time, like a smaller model is going to take less time to run inference. So definitely look out for like the 4 to 8B, potentially 32B models and fine tuning. If you need more general capabilities, you want it to think a bit longer, of course, look for larger models. And I would always start with first, running something in production, getting something up and running really quickly, but also trying out retrieval augmented solutions first before investing in fine tuning, just to validate that open source is actually right for you.
Yeah, that makes sense. This brings me to this question I always think about, and I think you kind of inspired this question, but maybe I'll ask it to Tobias because you deal with security. We are coming across a lot of people trying to answer the question around what is acceptable risk in a business, what is acceptable output from probabilistic models, when is it okay to say this is good enough? How do you feel like, are we converging on like real answers to that question, or do you feel like it's still an open field?
Absolutely. So yeah, that's a really good question. So just the way that, I guess what Voxel does is we identify these risky behaviors in warehouses. And these risky behaviors can lead to injuries. We're not identifying individuals, that's pretty clear. So just looking for hotspots. And I guess initially when Voxel rolled out, they didn't have anything. They didn't have any visibility into these systems. So any sort of visibility was helpful. But as our customers are getting more and more dependent on our systems, it's really important to hold ourselves to a high quality standard. And that's where a lot of our evals and curation of the evaluation sets is very, very important, right? How can we ensure that we are giving customers the recall that they're expecting, we're not missing anything if they're expecting real-time responses, and how can we make sure that we're also, while tuning for recall, we're not actually flooding them with a bunch of false positives. So it's something that's that we tread the line very carefully to think about, is how can we actually give them useful information while also not missing anything that's not. But yeah, it's an open question on how you tune and get to that specific number. And I think each company has their own approach.
Yeah, but yeah, obviously we're coming up with answers that companies are happy with and able to actually utilize in production. My, I guess, last question is for Vishaka. We started out, and I'll just tell you about me, I was super happy when ChatGPT could deal with documents, and all of a sudden I was building my little ChatGPT bots, and I was super happy. And then we had some more things that we could do. We could structure data. Eventually we could get outputs to be a little bit more structured. We got agentic workflows and MCP working. What's the next big thing? Or what's the thing that customers are looking for? Are they happy at where they are? Does everyone just want an MCP server now? Or what's the next step?
So depending on who you ask, I get we see questions from, well, any generic question, you should be able to use the graph and answer it, and we'll only ask it in natural language, and you cannot put specific tools behind MCP. It should just work, right? And we get into these discussions on hey, you try using text to SQL on more than one table, and even that doesn't work. And there are a gazillion examples on the web on how to use on how to write SQL queries, right? And so I think there is this, I think people want to live in this art of possible without realizing what it means when you go into production, which is why when you talk to people who are tasked with deploying things in production, they are living a very difficult life because the leaders want AI to show results. The research teams will go get results on POCs, and then there is this big gap, right? And it's hard to tell them that there is this gap and we gotta fill it, right? You somehow have to figure it out. So I think what we see coming is like more and more this stronger realization on we're gonna have to do better in terms of how you chart the path from POC to AI returns. And the other thing I also see, and I think it's gonna happen, is asking the question, what are we really trying to accomplish? Like, is the question agentify this any use case, or is the thing, okay, agents are the right answer for solving this problem for us? And then if you build agents, am I just doing one desktop agent, or am I actually thinking about the entire company's knowledge base? And am I thinking about the silos, the data silos? Permissions, exactly, right? How am I addressing those problems? I think there has to be like a more comprehensive approach, and I think that's what we'll see. Like, as people now realize there has been a lot of investment, what are the returns? And that's when we'll get into all these real world questions of, okay, well, now we are faced with reality.
Yeah, down in the implementation layer, you're always thinking like, what's your top layer? Is it the probabilistic layer, or is your top layer like a deterministic layer? And it kind of depends on the kind of risk you want, right?
Exactly.
Okay, I think we have a few minutes to ask questions from the crowd. If folks have any questions, please raise your hand, and I'll run to you. Anyone? Come on. We gotta find each other, though. There you go.
Yeah. Hey everyone, my question is, are there like tools, habits, or workflows that you guys have developed in the past couple of years that have helped you be more productive as like an individual?
Who wants to take that on?
I would say a guiding principle of mine, it comes from an ex-KCD comic.
Been a while.
Yeah, there's one, I forget the name of it, but it's great. It's basically this chart which shows how many times do you do things, like how frequently do you do it, and then how long would it take to automate it. And you can do a rough calculation to figure out, if you're doing the same thing and it takes you maybe like 5 or 10 seconds, but you're doing it like 100 times a day, then you can get great leverage by just automating those small little things. So I would say there's a lot of value in automating the small things, and if you just keep on automating those things, you're going to build up tons of momentum.
Thank you. Anyone else with a question? We have a fully informed up.
So I work at a university, and right now I can see the students are very anxious about AI. They don't know what they should learn, and they don't know what kind of jobs out there when they graduate. So do you have any suggestions, like what the skills that they need to survive in the AI world, to be prepared? Thank you.
I have very strong opinions on this. I think this whole, so I have very strong opinions because I learned everything from ground up, like how does the hardware work, how do the signals travel, all the way to assembly programming, to C, and then actually learning Python, which was surprisingly the hardest, even though Python is supposed to be the easiest, right? But what that made me realize is what's actually happening underneath. I think asking that question and understanding doesn't mean you're always going to be writing code in assembly. I haven't done assembly programming in years. But that understanding is very essential. Like this whole thing we were discussing about why do things not work in production, or what happens is because there's this excitement on, oh, this tool is letting me write so much code. But how do you know when it's not doing the right thing? And then why are some engineers benefiting so much compared to some others who are afraid of the job? Because the engineers who understand how things work, they can really 3x, 4x, 5x their productivity with a lot of these AI tools. So what I would say is like, I think you cannot avoid learning how to use AI to speed yourself. I think that's something that has to change in the curriculum if it hasn't already. But that also doesn't mean that you let go of the fundamentals. And I think the people who will survive this thing and actually thrive are going to be the ones who know how to use the tool to benefit themselves, to start getting actually into like what's next. Now I have time to think about what's the next frontier because I already did my job much faster. I don't know if you guys.
Yeah, I have a little bit of a different take on that. I think like for engineers, at least I think for the non-superhumans, I tend to understand one layer and then one layer below me. Right? I can't go like much deeper than that. And I think it's important at least to understand the layer where you are and the layer above you and the layer below you. Right? And so if you're at the AI layer, there's like a layer below usually, like what are you doing? If you're a BizOps person, you have to understand the underlying, say like supply chain and GTM strategies and all that, that's a layer below you, but you're using AI, right? And I don't view AI that differently from like being able to use a computer. Back when I had my first internship, it was in marketing. And I was the only person there who like really knew how to use a computer. I could program. And so they were very impressed with me. They were, wow, like I'm from Singapore. And so they're like, boy, wow, so impressed, And I'm like, I'm just doing like very basic programming, but like because of that, I was able to just like be so much better than everyone else, right? I don't view AI very differently. I think we're in San Francisco, it's a bubble. Everybody here really knows how to leverage AI, right? But outside of this bubble, like it's a new thing. Like you have to actively learn and like inculcate yourself. There is a difference between someone who's able to efficiently leverage it, and I know that I'm actually not in that camp yet. I do have skill issues, I think, when it comes to that.
It takes time.
It takes time, right? You have to almost be like really like learn how to speak the language of the AI. But yeah, I think just learn how to do that so that you can really learn how to use a computer and use technology, right? Last anecdote, a funny one. I think back in the day, people used to put Microsoft Word on their like resume. I can use Microsoft Word. I can use Microsoft PowerPoint, right? And I think now that should be a thing. Right? I can use Claude Code. I can use agents. Yeah.
That's awesome. Thank you guys so much. I'll give my 2 cents, by the way, because I'm like going around the country talking about tech anxiety. Let's chat later. I have a 30-minute talk on this.
Thank you.
Anyway, thank you guys so much for coming here, for taking the time, and we really appreciate you. I think we hit the time just about perfectly. And that's that. Yeah, thanks for coming.
Thank you, everyone.